In this video, we're going to learn how to classify different types of shapes. So there are a lot of mathematical shapes that you're probably already familiar with. For example, many of you know about a triangle, which is a shape that has 3 sides. Many students also know about squares, rectangles, etc., types of shapes that have 4 sides. Then we have things like pentagons and hexagons. Maybe you've heard of octagons. And again, these are just shapes with different numbers of sides. So we have 5 sides on a pentagon, 6 on a hexagon, and 8 on an octagon. And there are many different shapes that we work with. Now, in this particular video, we're going to focus on classifying 4-sided shapes, like the rectangles and the squares. However, just keep in mind there are a lot of other mathematical shapes. We're just focusing specifically on these because there are actually quite a few popular 4-sided shapes that we need to be familiar with and okay with based on their definition, and we can distinguish between different types of 4-sided shapes. So as I mentioned, we're going to focus on 4-sided figures. And at their most basic definition, a 4-sided figure is called a quadrilateral. So the first definition that you need in your notebook is quadrilateral. And a quadrilateral, by definition, is any 4-sided shape. Now, yes, this can be something like a square, but it could also be something that looks like that. That doesn't look like any specific shape that I know of that has a name, but it's 4 sides. We got 1, 2, 3, 4. And if we have 4 sides, we are considered a quadrilateral. So that's the first term that we need to know. Quadrilateral is a 4-sided shape. Now, within the quadrilateral family, there are a number of different 4-sided figures that we tend to work with quite a bit in the math world. And the first is called a parallelogram. So the definition of a parallelogram, which is our first word here, is a quadrilateral with 2 pairs of parallel sides. And remember that parallel sides or parallel lines are lines that go on forever and do not cross. So something can be noted as a parallelogram if it has 2 pairs of parallel sides. And so what we're going to look for is parallel line notation. Now, what we're going to commonly see when we have parallel lines is we're going to see little arrows. Arrows like these, so if we have one single arrow, those mean that those 2 sides, so right here and right here, are parallel. And if they were to continue on forever as lines, they would never touch. Then we can put, say 2 arrows on this side to denote that these 2 lines are parallel. So because we have 2 pairs of parallel lines, we know we have a parallelogram. So if you see a shape that notes that it has 2 pairs of parallel lines, you can assume that it is in fact a parallelogram. Now the next shape we're going to define is a rectangle. And by definition, a rectangle is a quadrilateral. And if you're wondering if it's a parallelogram, yes, because of the way it's set up, it is a parallelogram. But you don't necessarily need that in your definition. So a rectangle is a quadrilateral with 4 90-degree angles. Now, I know you're probably thinking, well, there are other things I know are true about a rectangle, and they probably are true. But what you need to know about a rectangle is that the definition of it simply means that it has 4 right angles. And right angles are denoted by drawing a half box in the corner. So the notation you need to see in order to assume something is a rectangle is the notation of the 90-degree angles in the corner. Now, there are other things that we know are true about rectangles. The first is that we do have 2 pairs of parallel lines. So you don't need this notation in blue, but if you know that those 2 sides, the 2 pairs of sides pair up and are parallel, that's okay. That's a good thing for you to know about rectangles. The other thing that we know about rectangles is that the opposite side lengths are equivalent. So we can denote that we have side lengths that are the same length by using little hash marks here. So if I put a single hash mark here and a single hash mark here, it means that these two sides are equivalent. And then similarly, if I go up here, if I wanted to note that these two side lengths are equivalent, I can put 2 hash marks and 2 hash marks. So the big thing you need to know about rectangles are the 90-degree angles, but if you also know that the opposite side lengths are equivalent and that it has 2 pairs of parallel sides, those are great details to also be aware of. The next term we're going to define is rhombus. And so a rhombus is also a 4-sided figure, so we can say that it is a quadrilateral. And because of the way that this shape works, we do end up with it being a parallelogram as well, so it fits into that parallelogram category. But a rhombus, by definition, is a quadrilateral with 4 equal sides. And I know a lot of you might be thinking, oh, that's a square. But that's actually not the definition of a square yet. There's a little bit more to a square. A rhombus, at its most basic level, is a quadrilateral with 4 equal sides. So the way that we denote that is we will say, using these little hash marks, that we have 4 equal sides. Every side length with a single red hash mark means that it has an equal side length there. So that's what we're going to see if we have a rhombus. Now, the other things that we know to be true about a rhombus, we know that it has opposite sides that are parallel, so you could include that parallel notation as well. But the big thing that we need for a rhombus are 4 equal sides. The next quadrilateral that we're going to take a look at is the square. And what a lot of students know about a square is that it has 4 equal sides, but there's actually a bit more to it than that. So a square is a quadrilateral. And because of the way that a square is built, it also happens to be a parallelogram. And a square specifically is a quadrilateral with 4 equal sides and 4 90-degree angles. So what you'll expect to see with the notation of a square is you'll expect to see 1, 2, 3, 4, denoting that we have 4 equal sides, and then 4 right angles. So that's the information that we need. Now, because of these 4 right angles and these 4 equivalent sides, we also end up with 2 pairs of parallel sides. So if you also note that those lines are parallel, that's perfect as well. Now, the last thing you need to know is a trapezoid, and a trapezoid is also a quadrilateral. And this one is different than the others because it is a quadrilateral with exactly 1 pair of parallel sides. So this means that we're not going to have the 2 pairs of parallel sides like we see with a parallelogram, but here we're only going to have 1. And if you look carefully, what you'll notice is that the top and the bottom in this particular shape are parallel. If they were to continue on forever, they would not cross. So that's our pair of parallel lines. If we take a look at the other 2 side lengths, and I kind of continue this line on, and then continue this line on, we can see that they do in fact eventually cross. So those are not parallel. So here we only have 1 pair of parallel sides, and that results in that being a trapezoid. Now the last thing I want to do here before we dive into some examples is I want to just kind of encompass what we've learned in a graphic organizer. So this is going to be focused solely on quadrilaterals, which means that we are focusing on 4-sided shapes. And quadrilaterals can break into a couple of big categories. The first category that we have is we have the category that contains 2 parallel pairs of sides. So we have 2 sets of sides that are parallel. When we have that, we have what is called a parallelogram. Now the second thing we see is we'll have one set of parallel sides. And when we do that, we have a shape called a trapezoid. Now, there is a whole other group over here that has 0 sets of parallel sides, and there's a lot of shapes that kind of fit in that, but we're not going to focus on any of those because they aren't really formal shapes that we work with quite often in the math world. But they do exist, right? We do have shapes that don't have any sets of parallel lines but have 4 sides. Now, beyond the parallelogram and the trapezoid, we can break this down further. So the parallelogram kind of breaks into 2 categories. It breaks into the category where we have 4 equal sides, or can have 4 90-degree angles. Our 4 equal sides are the rhombus. Any shape with 4 equal sides is considered a rhombus, and any shape with 4 90-degree angles is considered a rectangle. Now, if we have that one unique case where we have both 4 equal sides and 4 90-degree angles, that forms a square. So that's kind of our breakdown of the quadrilaterals that we've defined in this video. Now what we're going to do in each of these examples is we're going to look at the photo, we're going to look at the details given to us, and decide which definition it fits best. So when I look at this, what I notice is I have 4 equal sides because I have 4 side lengths that are all equivalent. So I can add that notation on if I would like. And then I see 4 right angles. Well, I know if I look back at my definitions, 4 equal sides and 4 right angles make something a square. So what we can write is that this shape is considered a square, and then we can provide a reasoning of because it has 4 equal side lengths and 4 right angles. So it pairs right up with the definitions of square in our notes. So let's take a look at this second example. What I notice is I have some side lengths that pair up. So I thought maybe at first that this might be a rectangle, but when I looked at my definition of a rectangle, it said that definition of a rectangle has 4 right angles, and this doesn't have right angle, notation in it. So then I looked at the fact and I noticed, hey, I have 2 pairs of parallel sides, and because of that, I have a parallelogram. And this is a parallelogram because we have 2 pairs of parallel sides. This next example here, when I take a look at the notation, I notice right away that I only have 1 pair of parallel sides, which automatically off the bat kind of limits what my options are. There's only one shape that has 1 pair of parallel sides, and that is the trapezoid. So I can immediately note that this is a trapezoid because we have exactly 1 pair of parallel sides. This next example here, I notice this one has side lengths that are equivalent as well, but unlike the example from a few slides ago, this one has 4 90-degree angles. So because I have 4 90-degree angles, but I don't have 4 sides that are all the same, I note that this is, in fact, a rectangle. And this is a rectangle because it has 4 90-degree angles. So if I take a look at this example here, what I notice right off the bat is that I again have 1 pair exactly of parallel sides. Now, even though this shape looks a little different than things I've seen before, because it only has 1 pair of parallel sides, I can assume, based on the definition, that this is a trapezoid, because we have exactly 1 pair of parallel sides. And if I look at this final example here, what I notice right off the bat is that these have 4 sides that are the same. However, I notice I have parallel lines based on the notation, but I don't have the 90-degree angles that would be needed to make this a square. So because I don't have 90-degree angles, but I have four sides that are the same length, I know that this shape needs to be a rhombus. And it's a rhombus because the definition of a rhombus is a shape that has four equal sides. That's exactly what I see here. Fits the definition perfectly. Four equal sides.